let's talk about clustering and correlation. That's the next step after we extract all those features, after you extract the behavior. So once you have everything, you need to cluster it, which means you need to store it in an intelligent way so that those are classified per all those different features that we extracted and the behavior. After that, you need to correlate so that all that information needs to be connected to make sense, okay? So the goal of clustering and correlation is to classify malware based on features and behavior extracted and correlate the information to understand the attack flow, the full picture. So we have clustering, which are basically nodes that we're going to call nodes, which are those different specific objects identified with a specific feature and a specific behavior. Okay, and those different objects creates the cluster, which are based on features, as I said, the timestamp, the imp hash, SSD, digital certificates, all those different features, static features can help us to classify it. Then we have properties. All the behavior that we detected, as you remember, keylogger, downloader, dropper, those are properties for that specific node, but that will help us also, as I said, to segregate. We have a group which has these specific features, but also is a downloader or a backdoor. That can help us to add more context into that specific group, or even segregate more than the clusters. Correlation. Once we have the information, we need to exploit it. How? Via what it is called GraphDB. Basically, you don't want to use a relational database because what you want to know is how you can connect the dots. And relational databases are not designed to do that. That's why it's very recommended to use GraphDB. It is a NoSQL database, and it is just a collection of nodes and hashes. Let me show you a picture. It's basically, as I said, it's just connection between nodes, relationships, and properties. All the different things that we just found, that we just collect, can be interconnected, okay? We're going to see some examples. And here is the correlation, okay? So basically, this is the final goal, to have from, as you can see at the middle, that specific MD5, which if you go and start analyzing it, you extract features, you extract behaviors, you will realize that, okay, this specific binary probably has a specific key, and then it will drop into specific systems, and then will connect on specific IPs. You know, the full picture of the attack is represented. This is from CrowdStrike that they documented from a specific organized crime organization, but this is exactly what we need to get as a threat intelligence researchers. Okay, so now you have the features, you have the behavior, you put it in a cluster, you put the properties of those different nodes, you classify them. So who is behind? At the end of the day, that's the most important goal, okay? To locate the threat actors behind the malicious clusters identified. So for example, you need to answer these questions. Where are they located? Which country? Who is sponsoring them? Sometimes it's nation state, can be Russia government, China government. What sectors of our industry are they targeting? Okay, so normally the groups are going to focus on a specific sector, financial institutions, banks, or probably they're just focusing on, you know, nuclear plants. And that also helps you to categorize the threat actors. C2 infrastructure, where are they located? What are the ports being opened? What is the operating system running? All those details help you to understand the C2 infrastructure. Tactics, techniques, and procedures. When you are a threat intelligence researcher, you will be always dealing with TTPs, which means how do they get into the system, the techniques being used, the procedures. All those different skills are going to define that specific group. And here probably is where you might need help from a reverse engineer, because you will exactly need to know like what is the encryption algorithm being used in order to decode the binary in memory. Or for example, where is the malicious code injected? It is in memory, or it is coming from the resources of the binary. All those details. How do you get persistence into the system via registry key, COM objects hijacking, different techniques. That's where reverse engineers can help the threat intelligence researcher. Okay, so you can also know in the initial compromise how they get into the system. Can be a spear phishing attack, can be just Facebook links fooling people to download malware. That also defines that specific group. Privilege escalation. How do they elevate privilege once they are inside the network? There are different techniques. As I said, persistence. Lateral movement, very important. How do they spread in the network? Different groups use different techniques. It's very important to define that specific group. Exfiltration strategy. How do they steal the information? Is it via HTTP post request? Is via a raw socket? Is via a proxy? How do they do it? And what information they are extracting? What is the format? Okay, so if no threat actor can be identified, the whole threat intelligence effort is useless. At the end of the day, okay, you found malware, you found features, you extract them, you cluster them, and even you detect them, but if you don't know who is behind, you cannot take down the organized crime. So let's talk about the GraphDB a little bit. So GraphDB, as I said, it is just a connection of nodes, or relationships and properties. So it's basically the nodes. You can understand the nodes as the components, like a file, binary, or a Word document, and those specific binaries has properties, features, right? The features that it is imp hash, timestamp, certificate, digital certificate, and also DNS-DB content and behaviors. So all that information is interconnected. Designed to store edges and properties for those edges. Okay? Edges, as I said, is like a binaries or malicious programs being analyzed. The properties are the features and behaviors that we just extracted in the previous steps. Okay? So, but what about the relational database? Well, the relational database, as you know, it is individual data unit as rows in the table, right? We have just rows in a table, and those are the individual data units. In GraphDB, those individual data units are nodes, okay, within a graph. So in the relational is rows, and then in GraphDB we call them nodes, okay? And then in RDBM's relationships, we have, table A is related to table B through a column in the middle, right? We have the table A with a column, table B with a column, and that column is connected with the other one, and we join both tables. In GraphDB relationships, we have node A related to node B via a property X. Like in this case, we have the binary A and the binary B, and we have a property, in this case imp hash, which can help us to connect both binaries. Okay, implementations of GraphDB, I would say that the most known one is Maltigo. Maltigo, made by Paterba company. It is a well-known solution that it is using what it is called transformations, and it's basically what is going to actually, let me show you quickly here. This is a view of Maltego. Is right, this one. So this is a view of looking of Maltego, which is pretty cool. You can see the connections right away. But this whole intelligence is not going to come automatically. This intelligence must be built by us based on our information that we just got, okay? It is good for open source intelligence, as I said, and it uses behind the scenes GraphDB. And here is it is the website if you want to check it out, okay? And next, another one also well known is Apache Tinkerpop. That supports multiple graph systems. So that you have different solutions for different purposes. Like if you're gonna have a big data, probably Maltego is not the best option. You might consider Tinkerpop. It is the website there. It is obviously available for trial. Neo4j is probably the most mature one. And actually it's pretty cool. It has a lot of tutorials, documentation that you might try it out. We're going to be doing some exercises with some of those GraphDBs in the labs, so make sure to check it out, okay? As a summary, guys, we talk about clustering and correlation, right? Clustering, which is going to help us to classify and store malware, but still, we need a GraphDB solution to exploit the information, right? So it's step by step. First, we cluster the information. We make sure that it is related based on features and behaviors. And once we have that information, we need to store it. We use GraphDB to store that information, and then also use correlation in order to have a graphical view of the attack flow. Okay? You can pick up a GraphDB solution based on your needs, or most of the time is based on the data, amount of data to use. As I said, Maltego is not good with a lot of data because you can imagine hundreds of thousands of nodes is not even visually possible. So there are many other solutions, okay? So, hope you enjoy it.